So today I've got Markos with me. Markos works for Kiraa. We got him on a couple of months ago. He's got a great background in actuarial studies. So today I really wanted to talk just a conversation with Markos around why sales forecasting is broken and how companies can fix it and what it means for them. So really just a brief introduction around why we got Markos on. I'll let Markos introduce himself shortly, but really the whole idea of bringing someone with such great analytical skills into the team is because then we can pair Markos with a developer to make sure that we've got really strong conceptual foundations for our forecasting products, and we've got the developers who can do what he needs to help businesses make the most out of their sales forecast. So Markos, I might get you to introduce yourself really quickly. Tell us about your background, what you love to do, why you joined Kiraa, and how you're going to talk to us today about sales forecasting.
Yeah, so Markos, I graduated from Macquarie University 2 years ago with a Bachelor of Actuarial Studies. I worked in logistics over the past few years, and I was brought on board to Kiraa to handle the new logistics client that they're onboarding. Yeah, so in my studies, I did a lot of mortality modeling and financial modeling. And I think that it has a lot of parallels to sales forecasting, because at the end of the day, all you're doing is you're looking at historical data to make a prediction about the future, which is what we try to do here.
So what's your experience in terms of the amount of data to get a good forecast? Is it, can you do it with just a couple of months of sales, or do you really need to sort of have transaction level information? What's the right amount of data to provide a forecast?
Obviously, the more clarity, the better. You can always aggregate data. You can't necessarily decompose it without making bold assumptions. So if you want to provide transaction level data, you can easily decide on how you're going to use that to, say, go for daily data. So you can go from transaction level data to sales per day, but you can you can't necessarily go from sales on a given day back to the granularity of the transaction. So it's always more data. When it comes to the amount of historical data, if you're trying to model seasonality, the more years in the past, the better. You need probably around at least 2 to 3 years of data to get a good model that models yearly seasonality and trends across the week, or weekly seasonality, for example.
The challenge you have there, if you're saying that you really want daily forecasts, if you're a business with a lot of customers and a lot of products, that could end up being hundreds of thousands of rows of data, right? Or even more, potentially millions.
Yeah, unless you're extremely experienced with manipulating data, it's like trying to look for a needle in a haystack, right? If you're dealing with a very large CSV file, hundreds of thousands of rows, it's not something that a human can go through one by one. You're going to need either coding experience to be able to filter out the data yourself, like understanding of the pandas library in Python, or maybe using R. You can't necessarily do that as a human on your own without in an Excel spreadsheet without it taking a lot of time.
Yeah,
that's the one true currency at the end of the day, right? Businesses aren't only trying to save money, but they're trying to save time. The more time you have, you can allocate that time to actually driving the revenue.
Okay, so talk me through it. What have you got? What are you showing me here?
So these are 5 different plants for a specific business that operates with revenue in the hundreds of millions. And they've asked us to create forecasting models to be able to predict sales for a specific plant. So these are the 5 plants. As you can see here, there are 4 different models that we've managed to generate. So I can flick between this. This is the naive model, which just looks at the time period before it, hence why it's a straight line.
Is that why it's called naive? Or why is it called naive model?
Called naive. This is what we call a naive or baseline model. We compare other models to this. So this is the baseline prediction. If other models beat this in the model metrics, like down here, mean average percentage error, mean average error, root mean square error. If the other models beat this naive approach, then we can say that the new model should be selected over this.
Okay.
So as you can see, there's 4 different models that we've made for this one specific plant. Mind you, there's 5 plants. So that's 20 models that have been tuned for in the matter of a few minutes, which has never been done before. I'll just flick through a few of them. Profit's my favorite one.
So tell me about profit model. What is that about? What's profit?
So Profit is a forecasting model developed by Meta. You can look at their documentation online. Pretty much, it takes into account a linear trend, a seasonal component, and holiday trends. So Profit uses a decomposable time series model, which is pretty flexible to many different trends. So as you can see here, YT, which is what we're trying to predict, is equal to GT, which is the trend function, and models non-periodic changes. ST is a seasonality component. So this is periodic changes. So think of like a sine wave. You might have seasonality across different seasons throughout the year. So for example, if you're a customer that sells a lot of paint products, you're gonna expect that around summer when the weather's hotter, that you're gonna sell a lot more product than you would in winter when it's wetter and nobody wants to buy a product. So you need a seasonal component within your model to capture this trend. And then the other component, which is HFT over here, is the holiday function. So HT, as per the documentation, represents the effects of holidays, but these can be public holidays, these can be promotional periods as well. You just have to specify them to a Profit when you pass it in as a data frame.
Okay.
That's the reason why I chose Profit for sales analytics, or casting, I should say, because it's pretty flexible to the nature of sales forecasting and that entire industry.
Awesome. So that looks like the profit model looks like it fits quite nicely. What is the MAPE tell you there about the quality of the model?
So the MAPE here says that the linear regression is the best one. However, if you look at the profit model, it's only off by it's only off by about 1%. So the profit model still is extremely good in terms of MAPE, and I would even opt for Profit just using the eye test, because as you can see here, if I switch back to linear regression, that doesn't look like a good enough prediction, or as good as a prediction as Profit. That takes into account all the different seasonalities throughout the year.
Particularly if you're looking at labor planning or stock planning, you need to know those movements, don't you? You want an early warning around what's likely to be dipping.
Yeah, because look at what this linear regression model is saying. It's saying that you're seeing a steady increase across the year of 2026. There's no dips, there's no seasonality whatsoever.
Which has never happened, right?
Yeah, which never happens. If you look here, the shape that's produced here, if you move it back across the chart, tends to overlay. So Profit tends to be more flexible to seasonal changes than all the other models like the linear regression and the naive approach, which don't have a seasonal component. So if you think about it, this whole model here is trained on about 3 years. So there's about 1,000 data points used to train this model. Every single new day is just an added data point. So if you're running it every single day, you're increasing the training data from 1,000 to 1,001. So you're not really on a day-to-day basis. You're not going to improve the model's performance that much by adding a new data point into it. But if you do have the ability to run it every single day, and at the end of the month, when you add 30 new data points, you might see a slight change and slight improvement in the model. It does get better over time as you feed it more data.
Yeah. So does having the model being run very frequently and providing daily updates give people more confidence as opposed to only seeing a model once a month?
Yeah, it would give people more confidence knowing that their model's consistently being updated.
Yep.
But to see true changes, it's kind of like going to the gym. You can train one day, but to see it's going to take about a month for you to see effects.
So you've done this model based on product and customer and plant by day. I mean, that sounds like an enormous amount of calculation work. What sort of time does it take to run that in practice?
So the plants took about like under a minute. It wouldn't even take much, probably like a few seconds to a minute, because there's only 5 of them. There's customers, as you can see here, there's 4,700 of them. It probably takes around, say, 15 to 20 minutes, maybe even 30 minutes to generate all 4,700 forecasts for them. Right.
Okay. So we could even schedule it to run at 3 o'clock in the morning so that when people arrive at work in the morning, they've got the updated forecast with the invoices up until midnight, perhaps.
Yeah, 100%.
Yeah. And what do you see as being the next big improvements we could make to this forecast to give customers even more comfort?
So the next big improvement that I see specifically is having more accuracy or greater accuracy around reporting the promotional period dates. So if I go back to this component here, the HFT, which are the special promotional periods and holiday dates.
And I think that's one of the key strengths of having this built inside Kiraa, because obviously for sales analytics, we do a lot of that backwards analytical work as a part of our sales analytics algorithm. What I'm hearing you say is that, you know, having ability to understand what happened and why it happened is really valuable for constructing models, because you can then treat the variations correctly as being promotional periods or outliers, those sorts of things. Is that right?
Yeah, that's absolutely right. We need accurate reporting and consistent reporting.
I think that's one of the challenges that most, certainly every organization I've ever worked in has, is that we treat sales forecasting almost as a separate exercise to sales reporting, as a separate exercise. So one of the beauties of Kiraa, one of the main reasons I designed Kiraa, is because we needed to have that layer where all of this information sits in a place where we can use advanced modeling tools and advanced analytical tools with the full contextual information. I think if you treat this as a silo, you're going to get a forecast that's not very reliable. But if you can treat this within the context of all of the information you've got, I think you're going to end up with a much more powerful model.
Yeah, 100%. And because it's so seamless, it takes away the monotony of the boring work of having to generate the forecast in the first place. They can just have it done in a matter of a mere minutes and spend the rest of the time actually like making sure that the data entry is consistent and accurate.
Yeah. Yeah.
So the bulk of the effort's in cleaning the data, making sure the data is good, and the other bulk is in the tuning. No
Yeah.
matter how good you are at tuning, however, just keep in mind that all models rely on good data. You put
Yep.
garbage, you're going to get garbage out. So,
Sure.
yeah.
Awesome. Okay, so that was really insightful. I'm glad you showed me that. I think you've made great progress. I think that's going to be enormously valuable for customers to be able to generate forecasts as a part of that Kiraa workflow. So what do you think? What do you think in terms of that would mean for customers having ability to generate forecasts like that at that level of detail every day? What are sort of things, some of the things that you think they will be able to do better than they can do today without that information?
So it'll baseline expectation. It'll allow them to plan resources better, but more importantly, it'll free up that time for employees to spend it on other more profitable activities. So as opposed to spending that time analyzing the data, fiddling around with spreadsheets, they can just have a forecast generated for them in a matter of mere seconds, tuned on a daily basis, and then they can spend the rest of their time actually doing things that generate revenue for the company and make them more productive.
So thinking about the skills that you learned during your actuarial degree, do you think that's something that people can just do without having an understanding of models, or is it something that it's like building models and refining them? Do you think that's a specialized skill?
It is somewhat of a specialized skill, but the only prerequisite to master any skill in this world is to have the desire to master it. So anybody can learn it just as long as they dedicate the time. But that's why those people are hired, the people that have the expertise in those fields, that have undergone the studying and whatnot. There's a reason that those people are paid to tune these models, because they have a deep understanding of statistics and of random variables and how to forecast them.
So how does your actuarial training help you do? How do you build forecast models? What is it that it gives you that say, for example, me who I've never done an actuarial degree. I'm mostly self-taught with a lot of stats. What have you got that I don't have?
So the background statistics, understanding hypothesis testing, understanding what statistical tests work in certain contexts. You can't use certain models in certain contexts. For example, you can't use a linear regression model to forecast a lot of things. A linear regression model operates under the assumption that the residuals, for example, are normally distributed. So you need to have the statistical background to run the diagnostics tests on the initial data to be able to see if the financial model or if the forecasting model that you're proposing to apply to that set of data is actually applicable. You can't just slap on any forecasting model onto any set of data. You have to go through the appropriate diagnostics.
In my manufacturing experience, forecasting has been a massive issue because a lot of the times you're dealing with long lead times for raw materials. So for example, if you're buying a specialized ingredient, for example, you want to buy something from Europe, it might take, 3 months for that to arrive on a ship, or you might have to air freight it. So having that extra visibility and having confidence of things that sit potentially 3 or 6 or 9 months out really helps organizations manage things like inventory, making sure that they've got the right stock available, but also, being able to reiterate those forecasts quickly means that if something changes, like for example, a tariff change or things like that, you can really adjust those very quickly. So when you're talking to some of the customers that we're dealing with, what are the things that they're looking at, some of the outcomes that they're expecting from the forecast that you deliver? What are the things they want to see in these models?
From customers that I've dealt with specifically, they're looking for the model to be flexible around special dates, so around promotional periods or public holidays. Typically around public holidays and promotional periods, you either see a spike or a dip, and you need to be able to train the model to detect that and predict it for future similar dates. So for example, around Christmas, a lot of people see a spike in demand because people want to rush to the stores and buy a product for Christmas. You can't use a normal prediction from November to predict for a holiday date like Christmas in December. You need to train the model to be able to detect that, hey, okay, over the past 5 years around Christmas time, within this time window, we see a spike in volume of around 20%. So this means that we should expect around about the same spike next year around Christmas.
Sure. So Chinese New Year, is that a complication? That changes every year, right?
Yeah, Chinese New Year is a complication that changes every year, but that's why forecasting models like Profit are pretty flexible around these, because the dates aren't static within the model. All that the model needs to know is that this event occurs at this time and causes this effect. So therefore, in the future, if we expect this public holiday to fall between these dates, then the effect should be changed to fall within those dates in our forecast prediction for the future. So these models are around those things.
And what does it mean for forecasting in terms of workforce and capacity planning? What does a good forecast let business leaders do that they can't do today?
So a good forecast will notify you of surges and dips in volume. So in that instance, you won't overbook staff, or you won't understaff and underbook the amount of resources that you need to handle demand for your business throughout that period. Obviously, you can see from there, you can reduce your costs quite significantly. The last thing you want to do is hire 20 workers to handle your freight, for example. If you only need 10 workers to handle the freight, you've essentially reduced your cost by 50%. The other instance is you don't want to book 10 people to handle your freight or 10 workers to handle your freight when really you need 20 workers to handle your freight, because then it's going to ruin your operations it's going to have ongoing domino effects throughout the later weeks, where you're going to have to spend more time, resources, and money playing catch up. So that's what they allow you to do. They give you greater visibility and they allow you to better plan your resources, ultimately improving your bottom line. That's the end goal, to improve a business's bottom line.
Yep. And so this thing obviously gives you visibility about what things are likely to happen. How do people feel confident that the forecast is good? Like how do you can produce something that's very good, but how do they know that they can trust it?
So there are metrics that we use to evaluate a model. Mind you, no model is perfect. If we had the ability to predict what the future holds with 100% certainty, well then you wouldn't be working a normal job. You'd just take that skill and you'd be working, you'd use it in the stock market and be a millionaire by tomorrow.
Yep.
So there are different model metrics that are used. Mean average error, mean average percentage error. They have to fall within a specified range. I typically aim for below 15%. That's considered acceptable. The other thing is you don't want a model to have an error of 0%, because that means the model's overfit to the data and won't have any predictive capabilities outside of the training data set that you've given it. The other thing is you have to combine what the model says with general human intuition. What these models do is they reduce the amount of time needed for a human to analyze the data. They give a good, pretty accurate baseline estimate you can then use that in conjunction with tribal knowledge or your past experience. Say, hey, the forecast for today might be a little off, but you can always fine tune a little bit of human intuition in there and override it. So these forecasting models are not gospel. They don't predict the future with 100% accuracy, but they are reliable the majority of the time. The same way that the weather forecast on your phone's pretty reliable. But we've all seen days where it's expected to rain and no one sees a raindrop. These days do happen, but that doesn't mean that the forecasting model should be put in the bin. It just means that these models provide us a pretty accurate, quick baseline for us to adjust expectations in the future.
Yeah, I think that's a great. I think when you can generate forecasts really quickly and they become repeatable, the work of generating a forecast falls away, and it really becomes a strategic advantage for people because they can plan their organization so much better if they've got foresight. So I think we're going to find a lot of customers are going to be really interested in the work that you're doing and being able to generate these forecasts really quickly, because that gives them the foresight. That's going to be really valuable in complex environments where you've got lots of products, lots of customers, lots of complexity. The ability to those forecasts that handle all of that complexity is a real strategic advantage. Would that be right?
Yeah, that's right. So it's going to save people the time of having to fiddle through the spreadsheets and asking what the problem is. Now they're going to have that time allocated to actually formulating solutions to that problem, using that information and applying it, as opposed to just trying to figure out, like, where are we at this point in time? What are we dealing with?
Cool. Thank you very much. That was really enlightening. Thanks again. I think you've done a great job with sales forecasting. I'm loving learning about stats from you, and I'm sure our customers are really enjoying hearing how you can apply all that great learning from your degree into solving real business problems. So I think that's a great thing to be working on. So well done.
Thank you. I appreciate that.